Ancient Egypt looks almost impossible when you stop and think about it. Imagine waking up thousands of years ago beneath a sky that offers almost no clouds, stepping outside into a landscape where shade can be more valuable than gold, and knowing that your entire day has to be organized around a sun you cannot escape. There is no air conditioner, no refrigerator, no electric fan, no modern cooling system waiting behind the wall, yet for thousands of years people built homes, raised families, farmed, traveled, worked, worshipped, and constructed some of the most famous monuments on Earth along the narrow green corridor of the Nile. So how did they do it? The surprising answer is that ancient Egyptians did not defeat the heat with one extraordinary invention. They built an entire way of life around it. Their homes, clothing, sleeping habits, work schedules, food, water, and even the way they used the desert itself were shaped by an environment where the difference between comfort and danger could come down to something as simple as where you stood at noon. And the first clue is hiding in the geography of Egypt itself. When we imagine ancient Egypt, we often picture an endless desert filled with pyramids, but the civilization was concentrated along a remarkably narrow strip of fertile land beside the Nile. The desert was always there, but the Egyptians learned to organize life around the river and the seasons that controlled it. That mattered because surviving extreme heat begins with one simple rule: do not waste energy fighting the environment when you can arrange your life around it. The Nile provided water and agriculture, while the surrounding desert created an environment where shade, airflow, and timing became essential. During the hottest part of the day, the smartest solution was often not to make yourself tougher, but to avoid unnecessary exposure in the first place. This principle shaped the Egyptian working day. Heavy outdoor activity could be scheduled for cooler periods, particularly early in the morning, while the strongest heat was better spent in shade or indoors. That sounds obvious to us, but imagine how different it feels when your entire society has no alternative. There is no machine to cool the room while you continue working. The sun becomes the clock. Dawn is opportunity. Midday is something to manage. Evening brings relief. And once you understand that, ancient Egyptian architecture starts to look less like primitive construction and more like environmental engineering. Many Egyptian homes were built from mud brick, a material made largely from Nile mud and plant material. Mud brick had a major advantage in an environment with enormous temperature swings: thermal mass. Thick earthen walls absorb heat slowly, delaying the movement of outside heat into the interior. During the hottest hours, the interior could remain more stable than the exposed landscape outside. Then, as temperatures dropped after sunset, the building could gradually release the heat it had absorbed. The wall was not magically creating cold air. It was slowing down the transfer of heat, buying people something incredibly valuable: time. Egyptian builders also understood the importance of shade. Houses could be arranged closely together, streets could remain narrow, and architectural layouts could reduce direct exposure to the sun. In settlements such as Deir el-Medina, where workers connected to the royal tombs lived, the dense arrangement of buildings created shaded areas that were far more comfortable than standing under the open Egyptian sky. And then there was one of the most fascinating spaces in the entire house: the roof. Flat roofs were not simply structural surfaces. In hot climates, the roof could become another part of the living environment. Once the sun disappeared, the roof was exposed to open air and the night sky, allowing heat to dissipate. Sleeping outdoors or on rooftops could therefore become an intelligent response to the nighttime environment rather than simply a sign of poverty. But architecture had another weapon, and this one involved something ancient Egyptians could never run out of: moving air. Windcatcher designs, often associated with the Egyptian term malkaf, were designed to take advantage of prevailing winds and direct air into buildings. Instead of using electricity to force air through a room, the architecture itself could help capture and redirect naturally moving air. The basic principle is remarkably simple. If you can bring moving air into a space and allow warmer air to escape, you can make the interior feel dramatically more comfortable without producing artificial cold. Ancient Egyptian evidence for such ventilation features is important, although exactly how widespread and technically sophisticated these systems were in different periods is still a subject that requires caution. But the broader principle is undeniable. Egyptian architecture repeatedly exploited shade, airflow, orientation, and the thermal behavior of thick walls. The same environmental intelligence appeared in something much closer to the body: clothing. If you were dropped into an ancient Egyptian city and expected to survive the summer, your first instinct might be to remove as much clothing as possible. But extreme heat makes that more complicated than it sounds. Direct sunlight adds heat to the body, so loose, lightweight clothing can provide shade while still allowing air movement and sweat evaporation. Linen, produced from flax, became one of the defining fabrics of ancient Egypt, and its breathability made it particularly useful in the climate. Fine linen became associated with wealth and status, while ordinary workers had access to much simpler forms of clothing. This distinction is important because ancient Egypt was not a civilization where everyone experienced the environment in exactly the same way. A wealthy Egyptian with servants, shaded spaces, fine clothing, and better access to food and water could experience summer very differently from a farmer or laborer working under direct sunlight. Heat was therefore not simply an environmental problem. It was also a social problem because the ability to avoid the worst of it was partly connected to status. And then comes the question that sounds almost too simple. What did they drink? In an environment where the body constantly loses water through sweating, hydration becomes a survival issue. The Nile was the central source of water, but ancient river water was not equivalent to the purified water that comes from a modern tap. Water quality varied depending on location and season, and people relied on different methods of obtaining, storing, and preparing drinking water. Clay vessels played an important role because earthenware can interact with water and the surrounding air in ways that can promote evaporative cooling. When a porous clay container allows tiny amounts of moisture to reach its outer surface, that moisture can evaporate, taking heat away from the vessel and cooling the water inside. It is a beautifully simple idea. Instead of spending energy to cool water, let the environment do part of the work. And ancient Egypt had another famous beverage, beer. But modern viewers should immediately forget the image of a modern cold lager. Ancient Egyptian beer was generally much thicker, less filtered, and often more nutritious than the beer most people imagine today. It could provide calories as well as fluid and became an important part of the food system. Workers could receive beer and bread as part of their rations, and records from Deir el-Medina show just how important these supplies were to organized labor. The famous workers' strike during the reign of Ramesses III is often remembered as one of the earliest recorded labor protests in history, and the delayed delivery of food rations was central to the dispute. That story gives us a remarkable glimpse into ordinary life. The people building and maintaining royal monuments were not simply anonymous laborers. They depended on organized systems of food, water, wages, rest, and supplies, and when those systems failed, they complained. But hydration was only half of the equation. Heavy sweating also means losing electrolytes, especially sodium. Ancient Egyptians obviously did not know the modern chemistry of electrolyte balance, but their diet naturally contained mineral sources through foods such as bread, fish, vegetables, and other staples. Salt and salt-containing foods could help replace some of what was lost through sweating. Again, there was no ancient sports drink designed by a laboratory. There was simply a food system shaped over generations by what was available, affordable, and useful. And this is one of the most important things to understand about ancient survival. People did not need to understand the science behind every successful habit for the habit itself to survive. If a building stayed cooler, people kept building that way. If a fabric felt better in the heat, it remained popular. If a work schedule reduced exhaustion, people repeated it. Knowledge could survive as tradition long before anyone understood the physics behind it. Even personal grooming could have practical advantages. Ancient Egyptian texts and archaeological evidence reveal a strong cultural emphasis on cleanliness and grooming, while shaving and hair management were influenced by both hygiene and social customs. Wigs, for example, were not simply decorative objects. They could also be removed, maintained, and styled differently from natural hair. But perhaps the most fascinating part of Egyptian heat management is that they did not treat the desert only as an enemy. The same dry environment that made life difficult also helped preserve the civilization's remains for thousands of years. In wetter environments, organic materials decay quickly. In Egypt's exceptionally dry conditions, however, objects such as textiles, papyrus, wood, and human remains could survive for astonishing lengths of time when conditions were favorable. The desert, therefore, became an accidental archive. It preserved evidence of people whose everyday lives would otherwise have disappeared. Even mummification was connected to this environment. Long before the elaborate rituals associated with royal burials reached their later complexity, the dry Egyptian environment could naturally desiccate bodies buried in certain conditions. Egyptian embalmers eventually developed increasingly sophisticated methods to reproduce and control that preservation process. Materials such as natron, a naturally occurring mixture of sodium salts, became central to drying the body. In other words, one of the harshest environmental conditions in Egypt became part of the civilization's technology of memory. The desert was simultaneously something people had to avoid, something they depended on, something that protected them from invasion across difficult terrain, and something that preserved their history after death. That is the deeper answer to the original question. Ancient Egyptians did not survive the heat because they possessed one secret technique that modern people have forgotten. They survived because heat management was built into the entire system of life. The house slowed the heat. The roof provided nighttime relief. The streets created shade. Clothing protected the body while allowing evaporation. Clay vessels could cool water naturally. Food and drink supplied energy and fluids. Work could be organized around the cooler portions of the day. The Nile provided the foundation for agriculture and settlement, and generations of experience turned all of these individual choices into a culture adapted to its environment. There is also an important lesson here that gets lost when we romanticize ancient technology. Ancient Egyptians were not somehow more naturally resistant to heat than modern humans. They had the same basic human problem. The body produces heat, the environment adds heat, and sweating requires water. What changed was everything around the body. Modern people often solve environmental discomfort by adding energy, air conditioners, fans, refrigerators, powered ventilation, mechanical cooling. Ancient Egyptians had almost no access to that kind of energy, so they had to work with geometry, materials, timing, shade, airflow, and habit. Their solutions were not always perfect, and life in ancient Egypt could still be brutally hot, exhausting, and dangerous. Heat stroke did not disappear because someone built a mud brick wall. But the remarkable thing is that an entire civilization learned how to make an extreme environment livable enough for ordinary life to continue for generation after generation. And perhaps that is why the most impressive Egyptian invention is not a pyramid at all. It is the ordinary house beside it, a family living behind thick earthen walls, moving through shaded streets, wearing breathable linen, storing water in clay, resting when the sun became dangerous, and returning to work when the temperature finally began to fall. None of those things look spectacular in a museum. There is no golden mask attached to them. No giant statue celebrates them. Yet those ordinary decisions are what allowed millions of ordinary people to live beside one of the world's most demanding climates for thousands of years. The pyramids tell us what ancient Egypt could build. The houses, clothing, food, schedules, and water systems tell us how ancient Egyptians could live. And once you see the civilization that way, the desert stops looking like a place they somehow endured. It becomes the environment they learned to read. They could not lower the sun. They could not move the desert. They could not turn the Nile into an air conditioner. So they changed everything they could control, the walls around them, the clothes on their bodies, the hours they worked, the places they rested, and the way they used the resources around them. That was the real Egyptian advantage. Not superhuman endurance. Not a lost magical technology. Just thousands of years of adaptation, observation, and accumulated knowledge. And maybe that is the most surprising part of all. The people who lived beside the pyramids were solving the same basic problem we solve every summer today. How do you stay comfortable when the world outside is trying to heat you up? We reach for a thermostat. They reached for shade, mud brick, linen, airflow, water, and timing. Different tools. Same human problem. And if you had to spend one entire Egyptian summer without electricity, without air conditioning, and without a refrigerator, would you actually be able to adapt to their way of life, or would the desert win by noon?